Let me tell you about the day everything changed at the Galactic Engineering Academy. The day we accepted a human. I, Professor Kylax Brightwing, pride of the Centaurian scientific elite, have presided over the quantum physics department for 300 years. And never, in all that time, had I seen such an absolute disruption of proper academic order. You should understand something about our academy. We're not just any school floating among the stars. No. The Galactic Engineering Academy represents 9,000 years of scientific achievement from 37 spacefaring civilizations. Our crystal spires pierce the atmosphere of Centauri Prime like needles of pure thought. Each building houses laboratories that would make your finest research facilities look like children playing with blocks. My office sits at the highest point of the quantum mathematics tower, offering a commanding view of our 3 artificial suns. Below, anti-gravity platforms ferry students between buildings, their crystalline surfaces casting rainbow patterns across our perpetually twilight sky. The very air vibrates with the hum of calculation engines and probability matrices. This is where we shape the future of galactic civilization. And then Marcus Rivera walked in. He just stood there in my office, looking around like a tourist who had wandered into the wrong dimension. His entrance exam results had caused quite the uproar among the Council of Deans, let me tell you. The human had somehow solved the impossible section, the one we include specifically to humble overconfident applicants. The truly baffling part? He solved it using what he called pencil and paper. Pencil and paper. While every other candidate interfaced directly with our quantum computing matrices, this human scratched away with processed tree pulp and crystallized carbon. My fellow professors insisted it must have been a fluke, perhaps an error in the testing matrix, or even a security breach. But no, every investigation confirmed the results were legitimate. Ancient academic bylaws forced me to accept him into the most prestigious engineering program in known space. Looking at him that first day, I could not help but notice how small he seemed. Most of our students tower over him by at least 2 meters. Their bioluminescent scales or crystalline exoskeletons mark them as the elite of their species. But Marcus? Completely ordinary. Plain pale skin, dark hair, and those ridiculously inefficient binocular eyes. No extra limbs, no neural interfaces, not even basic genetic enhancements that most spacefaring races consider essential. The only remarkable thing about his appearance was that expression he wore. That slight curve of his lips that humans call a smile, suggesting he knew something we did not. It was unsettling. I said to him, with all the condescension I could muster, "Welcome to the Galactic Engineering Academy, Mr. Rivera. Do try not to blow anything up." I even added a light chuckle from my secondary breathing apparatus to emphasize just how little I expected from him. His response? He looked me straight in my primary visual cluster and said, "Thank you, Professor Brightwing. I will do my best to exceed your expectations." Little did I know just how prophetic those words would prove to be. Words spread through the Academy's neural networks faster than a quantum particle cascade. Within hours of Marcus Rivera's arrival, every student from the crystalline Arcturians to the gaseous nebulons knew about the human who had achieved the impossible on the entrance exam. Let me share with you the exact moment that sparked the controversy. During the exam's final challenge designing a theoretical faster-than-light drive, Marcus did something that our sensors initially registered as a malfunction. While other candidates immersed themselves in complex holographic models and ran simulations through our quantum computers, this human pulled out what he called a notebook and started drawing. Yes, drawing. With his primitive carbon stick, he sketched diagrams that looked more like ancient cave art than proper engineering schematics. The monitoring AIs nearly shut down his exam, thinking he was experiencing some sort of mental breakdown. But then something extraordinary happened. Marcus started annotating his drawings with mathematical formulae, not the elegant quantum equations we use, mind you, but a bizarre hybrid of Earth mathematics and what he had gleaned from our public scientific archives. He approached the problem like a child building with construction toys, but somehow it worked. The other students, led by the brilliant but insufferable Zara Luminar, treated him like a virus in their perfect system. Zara, with her 6 iridescent tentacles and hyperspace-capable brain, couldn't fathom how a being who couldn't even process 11-dimensional calculations naturally could be allowed in the same classroom. During our first practical exercise in quantum field manipulation, the students were tasked with stabilizing a micro-singularity. Standard procedure involves neural linking with our containment fields and performing precise adjustments through thought control. Marcus, lacking the neural interfaces the other students took for granted, rigged up what he called a manual override system, using, if you can believe it, knobs and levers. The laughter in the laboratory that day could have destabilized a small moon. Zara's crystalline laugh chimed the loudest, her tentacles wiggling with mirth. But then Marcus did something that made every student's secondary respiratory system stop mid-breath. He achieved perfect containment stability in half the time of his closest competitor. How, you ask? Instead of following our standard protocols, he treated the singularity like something he called a spinning top, a children's toy. He manually adjusted the containment field's resonance frequency by observing patterns that our automated systems were programmed to ignore as irrelevant noise. Professor Nexus Voidweaver from the Theoretical Applications Department actually short-circuited his third neural cluster trying to understand the underlying principles. The human's approach violated at least 15 laws of accepted quantum manipulation theory, but the results were undeniable. Even more puzzling were his study habits. While other students interfaced with the Academy's vast knowledge networks during their rest cycles, Marcus would sit in the arboretum, surrounded by actual physical books. When asked why he didn't simply download the information directly, he claimed that the act of reading and taking notes helped him think better. As if there could be anything more efficient than direct neural interface. Yet I found myself watching him through the security feeds, noting how he would stop reading occasionally, stare into space with that peculiar smile, and then frantically write something in his notebook that would later turn into an innovative solution to a supposedly impossible problem. By the end of his first week, Marcus Rivera had become something of a living paradox in our halls of learning, too incompetent to be taken seriously, yet too successful to be ignored. The betting pools, strictly forbidden but thriving nonetheless, were split between him suffering a spectacular failure and somehow revolutionizing our entire field of study. Looking back now, I realize we were all asking the wrong questions. We were so focused on how a human could compete with our advanced methods that we never stopped to consider whether our methods were truly as advanced as we believed. Now, don't get me wrong. Marcus Rivera's time at the Academy wasn't all unprecedented successes and paradigm-shattering innovations. Oh no, there were failures. Spectacular, catastrophic. How did he survive that failures that had our insurance algorithms crying digital tears? The most memorable disaster came during his attempt to master our standard quantum harmonization protocols. Every first-year student must learn to synchronize their consciousness with our quantum computing systems. It's as basic as breathing for most species. But humans, with their stubbornly analog brains, simply aren't built for it. Marcus's first attempt ended with him unconscious on the floor, bleeding from his nose, while the quantum interface sparked and smoked. The second attempt somehow reversed the gravity in half the laboratory. The third. Well, let's just say we're still finding temporal anomalies in that particular corner of the building. Small objects occasionally appear 30 seconds before they're dropped, which is playing havoc with our cleaning drones. But here's the truly infuriating part. Instead of accepting his clear biological limitations, Marcus started sneaking into Workshop Lab 7 during the station's night cycle. Our security systems registered his presence, but due to some obscure bylaw about student initiative that I'm now deeply regretting, we couldn't stop him. All through the monitor feeds, I watched him work night after night. He would sit there, surrounded by holographic projections of both our advanced quantum theories and what he called classical Earth physics. Pages of notes covered every surface, filled with the most bizarre combinations of mathematical systems I had ever seen. What in the name of the three suns was he trying to do? Combine thousand-year-old Earth formulas with our advanced quantum mechanics. It was like watching someone try to upgrade a fusion reactor with a steam engine. But then he started building something. Using spare parts from our recycling units and components he fabricated himself, Marcus created what he called an analog quantum interface. The device looked like it had been cobbled together from garbage, all exposed wires and manual controls, with actual physical displays instead of neural projections. The first time he activated it, every quantum sensor in the Academy went haywire. Zara Luminar burst into the lab, all 6 tentacles raised in alarm, expecting to find a catastrophic breach in spacetime. Instead, she found Marcus calmly adjusting knobs on his contraption while monitoring readouts on a physical screen. Here's what none of us understood at first. Instead of trying to force his human brain to interface directly with quantum systems, he had built a device that translated quantum data into forms his natural senses could interpret. He called it biomechanical intermediary translation, but really, it was more like building a hand-operated crane instead of growing extra arms. The truly revolutionary part, his crude device actually worked more efficiently than our standard neural interfaces. While our students processed quantum data through layers of bioengineered neural enhancement, Marcus's analog system went straight from input to output with virtually zero lag. Professor Nexus Voidweaver spent 3 full cycles analyzing the device, trying to understand how such primitive technology could outperform our advanced systems. The answer, when it finally came to us, was embarrassingly simple. We had become so focused on enhancing ourselves to interface with quantum systems that we never considered simply building better interfaces. This discovery led to Marcus's first major breakthrough in the field of quantum engineering. By combining Earth's classical physics principles with our quantum mechanics, he began developing an entirely new framework for human quantum interaction. A framework that would eventually lead to, but no, I'm getting ahead of myself. The important thing to understand is that Marcus's early failures weren't really failures at all. They were the necessary steps in breaking down our preconceptions about how things should work. Though I would never admit it to him directly, watching him struggle and persist taught me more about innovation than 3 centuries of academic research. You know what the most annoying thing about revolutionary discoveries is? They never happen when you're ready for them. Oh no. They burst into existence at the most inconvenient moments possible, usually during what appears to be a complete disaster. And that's exactly what happened on the night that changed everything. It was well past midnight by station time. Marcus had been working on his latest project attempting to improve the efficiency of our standard faster-than-light drives. Most of the faculty had already dismissed his efforts as a waste of resources. After all, our current drives were the product of 9,000 years of development. What could one human possibly contribute? I was in my office, finishing up some grading, when every alarm in the quantum lab started screaming. The monitoring systems were registering impossible readings, quantum states that shouldn't exist, energy patterns that violated fundamental laws of physics. My first thought was that Marcus had finally managed to blow himself up. Racing to Workshop Lab 7, I found him standing in front of his jury-rigged testing apparatus, mouth hanging open, staring at readings on his primitive digital displays. The air itself seemed to be shimmering, like heat waves rising from hot pavement. That's when I noticed something even more disturbing. The quantum containment field was operating at 300% beyond its designed capacity, yet showing no signs of instability. "What have you done?" I demanded, expecting to find some horrific breach of safety protocols. Instead, Marcus turned to me with that infuriating smile of his and said something that made absolutely no sense at the time. "Professor Brightwing," he said, "what if we've been thinking about quantum space all wrong? We've been trying to punch through it, but what if we could just fold it instead?" Fold it? The very idea was absurd. Our entire understanding of faster-than-light travel was based on creating quantum tunnels through space-time. The energy requirements were enormous, yes, but it was the only way to achieve superluminal speeds. Or so we thought. Marcus pulled up a simulation on his screens, but instead of showing the standard quantum tunnel formation, it showed something entirely different. The space-time field wasn't being punctured or tunneled through, it was literally folding in on itself, creating what he called a quantum envelope. The most maddening part? The principle behind it was embarrassingly simple. Marcus had accidentally discovered it while trying to compensate for a flaw in his testing equipment. His analog interface had been malfunctioning, creating unintended resonance patterns in the quantum field. But instead of disrupting the experiment, these patterns had revealed an entirely new way of manipulating quantum space. "Think of it like paper," he explained, grabbing one of his notebooks. "You can try to punch through it, that's our current FTL method. Or," he folded the paper, bringing 2 distant points together. "You can just fold it." The implications were staggering. His method required less than 1/10 of the energy of conventional drives. The quantum stress on surrounding space was negligible. And the theoretical speed limitations? They didn't just exceed our current technology, they broke through barriers we had assumed were fundamental laws of physics. Of course, I didn't admit any of this at the time. Instead, I demanded he prove it wasn't just a malfunction. So right there in the middle of the night, Marcus set up a microscale test. He placed 2 quantum-linked particles at opposite ends of the lab, then activated his modified field generator. The result? Well, I still get chills remembering it. The particles didn't just quantum tunnel to each other as expected. They moved, without crossing the space between them. One moment they were separated by 20 meters, the next they were occupying the same space. The quantum field measurements showed no disruption, no tunnel formation, just a gentle fold in the fabric of spacetime itself. I wish I could say I immediately recognized the magnitude of what we were seeing. Instead, I spent the next 3 hours trying to prove it was impossible. I called in Professor Nexus Voidweaver, who called in Professor Lyra Stardenser, who called in half the quantum physics department. By morning, Workshop Lab 7 was packed with the finest minds in the academy, all staring in disbelief at something that should not have been possible. And there was Marcus, still in his wrinkled clothes from the day before, patiently explaining his discovery using notebook paper and hand-drawn diagrams. The human had done it. He had found something that 9,000 years of advanced alien civilization had missed. Success, as it turns out, has a funny way of making enemies. The academic board convened an emergency session the very next day, and let me tell you, it was about as pleasant as a solar flare in an unshielded ship. Dean Quantum, with his characteristic array of pulsing light patterns expressing extreme skepticism, led the charge. The very foundation of our understanding of faster-than-light travel cannot be overturned by a primate with a pencil. His light patterns turned an interesting shade of fuchsia as he said this. The boardroom erupted in a cacophony of various alien communications. The gaseous members of the board were turning particularly acidic colors, while the crystalline representatives vibrated at frequencies that threatened to shatter our drinking glasses. But nobody, and I mean nobody, was more outraged than Zara Luminar. Our top student had spent 3 years developing improvements to the conventional quantum drive system, and here was this human upstart suggesting her entire approach was fundamentally flawed. During the next week, she launched what humans would call a smear campaign. Her 6 tentacles were constantly in motion, manipulating data streams, pulling up every minor flaw in Marcus's previous experiments. Remember the gravity reversal incident? Zara had it playing on loop in the main atrium. The temporal anomalies. She submitted a 15,000-word paper suggesting they were proof of Marcus's fundamental misunderstanding of quantum mechanics. But her masterstroke came during the peer review process. Zara discovered that Marcus's original calculations included references to something called YouTube tutorials. Can you imagine? A portion of his groundbreaking theory was apparently inspired by public entertainment broadcasts from Earth. The Academy was ready to dismiss the entire discovery as a fluke, a random accident by an unqualified student. And then something unexpected happened. Professor Lyra Stardenser, the reclusive genius who had developed half our current quantum theory curriculum, emerged from her private research complex. Now, you have to understand something about Lyra. She's what we call a phase walker, a being of pure energy who exists simultaneously in multiple quantum states. When she speaks, reality itself seems to vibrate in harmony with her words. She hadn't attended a board meeting in over 50 years, claiming they existed in too limited a set of dimensional states for her taste. But there she was, her form shimming with barely contained quantum energy, facing down the entire academic board. "We have become," she said, her voice resonating across multiple dimensions, too attached to our own elegance. "We mistake complexity for advancement." The room fell silent. Even Dean Quantum's light patterns dimmed to a respectful glow. Lyra continued, her form splitting into multiple quantum echoes as she spoke. "The human's theory is beautiful precisely because of its simplicity. We sought to master quantum space. He simply asked it to cooperate." She then did something unprecedented. She offered to personally oversee Marcus's continued research. Even Zara's tentacles went still with shock. Having Lyra Stardenser as a mentor was like having gravity itself decide to give you personal flying lessons. The board couldn't refuse. Lyra's reputation was unassailable, her genius beyond question. But that didn't stop the whispers, the subtle sabotage attempts, the constant scrutiny waiting for any sign of failure. Marcus, for his part, seemed almost amusingly oblivious to the political storm swirling around him. He just kept working in his lab, refining his theory, building increasingly sophisticated versions of his quantum fold drive. The only sign that the pressure was getting to him was the increasing number of empty coffee containers in his workspace. Even I found myself being drawn into the controversy. Other faculty members would stop speaking when I entered rooms, their sensory organs radiating disapproval. After all, I was the one who had allowed this human to continue his unorthodox experiments. In their eyes, I had helped unleash this chaos upon our orderly academic world. The day of the demonstration arrived with all the subtlety of a supernova. The grand auditorium of the Galactic Engineering Council was packed with the most brilliant minds in known space. Quantum physicists, drive engineers, and theoretical mathematicians from 37 species had gathered to witness either a revolution in space travel or the most spectacular failure in Academy history. I spotted Zara Luminar slithering through the crowd, her tentacles twitching with barely contained anticipation. She had spent the previous night in the demonstration lab for what she claimed was routine maintenance. The security feeds had mysteriously malfunctioned during her visit. How convenient. Marcus stood on the presentation platform, looking impossibly small next to his jury-rigged quantum fold drive prototype. The device was a stark contrast to the elegant machinery usually displayed in these halls. Exposed wiring wrapped around manual control interfaces, and physical displays flickered with real-time readings. Next to him, Professor Lyra Stardancer's quantum form rippled with supportive energy patterns. Grand Chancellor Vex of the Engineering Council rose from his gravity throne, his crystalline form refracting light across the audience. "Let the demonstration begin," he intoned, each word sending harmonic vibrations through the chamber. Marcus activated the primary power sequence. The quantum fold drive hummed to life, its readings showing perfect initialization curves. Then everything went wrong. The power coupling to the main quantum matrix started fluctuating wildly. Danger readings flashed across every display. The sabotage was obvious, at least to those of us who knew what to look for. A lesser being might have panicked. The council was already murmuring disapprovingly, their various sensory organs radiating skepticism. But Marcus, he smiled. That same infuriating smile he had worn on his first day at the academy. Without missing a beat, he reached into his pocket and pulled out a roll of what he called duct tape. The audience watched in horrified fascination as he literally taped together a manual bypass for the sabotaged power coupling. Professor Nexus Voidweaver nearly fainted at this blatant violation of safety protocols. Working with swift confidence, Marcus rerouted power through his backup systems, compensated for the intentional misalignments, and even used his primitive Earth phone as an auxiliary processor. The quantum fold drive's hum changed pitch, becoming deeper, more stable. "Ladies, gentlemen, and beings of all configurations," he announced, his voice steady, "what you are about to see is not just a new way to travel through space. It is proof that sometimes the simplest solution is the best one." With that, he pressed the activation sequence. The quantum fold drive pulsed with a soft blue light, nothing like the harsh violet glare of standard quantum drives. A gentle hum filled the auditorium, barely louder than a whisper. For a moment, nothing seemed to happen. Zara's tentacles began to wiggle with smug satisfaction. Then everyone's sensors started going crazy. The test probe, positioned at the far end of the Academy's testing range, simply vanished. No quantum tunnel signature, no massive energy burst. It just ceased to be where it was and appeared 50 light-years away. The readings were impossible. Energy consumption was at 8.2% of standard quantum drive requirements. Spatial distortion was practically non-existent. The probe's quantum state remained perfectly stable throughout the transition. Even the backup coffee maker Marcus had attached to the drive was still functioning. Grand Chancellor Vex's crystalline form vibrated so intensely that small fractures appeared in his outer layer. Professor Lyra Stardancer's quantum form split into 1,000 smiling echoes. And Zara? All 6 of her tentacles went limp with shock. Dead silence fell over the auditorium as the probe made a second jump, then a third, each one more stable than the last. The efficiency readings kept climbing. By the 5th jump, the energy consumption had dropped to 5% of standard requirements. Marcus stood there, calmly adjusting his handmade controls, that same smile still playing on his lips. For what may have been the first time in the history of the Galactic Engineering Council, 9,000 years of scientific certainty had been upended by a human with duct tape and determination. The changes that followed were, shall we say, rather dramatic. The Academy's admission policies were completely overhauled. No more requiring neural interfaces or quantum-enhanced consciousness. No more dismissing solutions because they looked primitive or unusual. Zara Luminar, of all beings, became Marcus's most dedicated collaborator. Her tentacles proved quite adept at managing his analog controls, and their combined insights led to even further improvements in the quantum fold technology. Professor Lyra Stardenser established a new department specifically for studying unconventional approaches to quantum engineering. She called it the Rivera Initiative, much to Marcus's embarrassment. As for me, well, I had to admit something that no self-respecting member of the Centaurian scientific elite should ever have to admit. I was wrong. Gloriously, spectacularly, enlighteningly wrong. We thought we were teaching Marcus Rivera about advanced engineering. Instead, he taught us that real innovation doesn't care about your credentials, your technology level, or even how many tentacles you have. Sometimes all it takes is a curious mind, a pencil, and enough duct tape to worry a safety inspector. Now, if you'll excuse me, I have a class to teach. There's a new human student who just arrived, and she's carrying something called a Swiss Army knife.